talked about degree measures around the circle in our last piece of notes, and today we're going to talk about radian measures. So there's another way to measure around a circle, and that's by using literally the radius of the circle. Okay? So let's say I have my x and y axis, and we were saying this was 0 degrees, and we traveled around the circle 360 degrees. Okay? But now we're going to measure instead in radians, and you guys already know some relationship to the radius and the circumference, which is literally what we're measuring when we're measuring these arcs here. So you guys know the circumference is equal to 2 pi times the radius. Okay? So if we were to measure the circumference in radians, in other words, how many radii does it take to go around the circumference of the circle? Basically, if we divided both sides of this by the size of the radius, take the circumference, divide it up into radii, pieces of the radius, every time. So that means just like we called this 0 and all the way around we called 360 degrees, in this radian measurement we would call this 0 and all the way around we would call it 2 pi. So this gives us reference for a new type of measurement. You learned about central angles and intercepted arcs in geometry. So a central angle goes from the center of the circle and intercepts some arc along the edge. So this would be the central angle that I've marked with theta, and this would be the intercepted arc. Okay? And that angle, we've normally measured it in degrees, but now we know we can measure it with this radian measurement as well. Okay? And what's going to help us today, if we know that 0 and 360 degrees are the same thing as 0 and 2 pi radians, there are some things that we can figure out sort of quickly. So if around the whole circle is 2 pi, then one time around the circle is pi. So the place we called 180 degrees in degrees is called pi radians, okay? Which means the place we called 90 degrees in degrees would be half of pi radians, or pi over 2. So actually this ratio right here, 180 degrees is equal to pi, is the ratio that people prefer, and we basically use this like unit conversion. If you have degrees and you want to convert it to something that's in radians, you need to multiply your degrees by some number that's equal to 1, where the degrees will cancel and you'll be left with radians. And so we would use 180 degrees for pi radians. You could use 360 and 2 pi, but it would just reduce to the same thing. Similarly, if I have radians, but I want to see what that means in degrees, I would want to multiply my radians by some value of 1 that would cancel out the measurement of radians and leave me with degrees. Meaning I would have to know an amount of radians that's equal to an amount of degrees. And again, that would be this version of pi and 180 to leave me with that value. So the first thing we're going to look at is just converting them. So we're going to change each degree measure to radian. So for part A, we have 45 degrees. So I'm going to multiply that by some amount of degrees over radians. And remember, the ones I knew were equal were pi to 180. And this is going to give me my result. So 45 happens to go into 180 4 times, and the degree measurement will cancel out. And I will be left with pi over 4 radians. For part B, same idea. I have negative 225 degrees. And I'm going to multiply that by pi radians over 180 degrees. The degrees will cancel out. Okay. 45 goes into 225 5 times and into 180 4 times. So here, this would be the same as negative 5 pi over 4 radians. If we are given radians and we want to convert to degrees, we can do the same. So here you see we have pi over 3 radians we'd want to multiply that this time so that the radians will cancel and leave us with degrees. So pi radians for every 180 degrees. So here pi and pi cancel, and 3 goes into 180 60 times. The measurement of radians will cancel, so I'm left with 60 degrees. So we want to be able to convert back and forth between these two measurements, and soon we're going to have certain pieces of them memorized that we use commonly. All right, so next we want to find one positive and one negative coterminal angle with each. So 11 pi over 4 So if you're having a hard time understanding at first what this is, you could convert it and convert it back, but we soon want to. So 11 over 4, 180 degrees over pi. 4 goes into 180 45 times. And 11 times 45 is 465 degrees. So this is the same as 465 degrees, so that would be 360 degrees. Sorry, 495 degrees. Can't multiply. So that would be 360 degrees, and then another 135 degrees, which would end us right over here. Okay? So one positive and one negative coterminal angle with this. So one positive angle would be the one that's not 495 degrees, but just from 0 to here, which was the extra 135 degrees that we went. The negative one would be from 0 to here this way, which would be 180 plus another 45, so 225 degrees negative. And then we would convert these back to radians. So you should be able to do the conversion and then make sure that you get the right answers that we get here. So 135 degrees should convert to 3 pi over 4. Okay. And negative 225 degrees should convert to negative 5 pi over 4. And we just did that one in the last example. So 3 pi over 4 radians. So again, you have a couple choices here. You can convert it to degrees to see where that really is. Or we just saw that 135 degrees was 3 pi over 4. So they are referring to 135 degrees, which is here. Okay. So a positive coterminal angle, I can't use 135 because that's the same as 3 pi over 4. So to get a positive one, I'm going to go all the way around and then land there. Okay. So I'm going to do this. So that's 135 plus 360, which is 495. Okay. For the negative one, I'm going to go this way, which is negative 225, and then I'm going to convert these back. So 495 happens to be what we started with in the last problem, so I happen to know that's 11 pi over 4. And then negative 225 we've seen in the last two problems, so you should be able to convert it or remember it, and then you'd have negative 5 pi over 4. Okay. So if you have to rely on converting, then do that, and then we'll find some other things that will help you remember as we get more familiar with these measurements. So just like in the last notes, we want to be able to find sine, cosine, or tangent of specific given angles. So this asks for tangent of negative 2 pi over 3. So that might freak you out, but if we convert this to degrees, pi radians over 180 degrees, pi will cancel, 3 goes into 180 60 times. So this is the same as a negative 120 degrees. Negative 120 degrees, let's see, would be right here. And then remember, we build a right triangle back to the x-axis to know something about that. So we're going to look at this reference angle that's not 120 right here, but happens to be 60. Okay? So this is my triangle. I have this guy where this is 60 degrees, okay, which means I know I have a 30, 60, 90. And the relationship is the short side, you double that to get the hypotenuse, and you multiply that by rad 3 to get the other leg. So I'm supposed to calculate the tangent in this case. So the tangent is opposite over adjacent, or y over x. So I'm putting n rad 3 over n. Now, pay attention, though, where we are in the quadrant. The x here is negative, and so is the y. So when I put this ratio together to find the tangent of negative 2 pi over 3, I'm going to do y over x, okay, or n rad 3 over n. But both of them are negative because of the quadrant. But luckily here the negatives cancel out, and so do the n's, and I'm just left with rad 3 as the tangent. For the sine of 3 pi over 4, again, unsure of where this is. 3 pi over 4. Convert it to degrees. 4 goes into 180 45 times. 3 times 45 is 135. So we're looking at 135 degrees. So 135 degrees is here, 45 degrees away from the axis. So remember, even though I'm at the position of 135 degrees, I use the 45 degree reference angle to build a triangle. But what 135 is going to do about the problem is it's going to make the x be negative but the y be positive because I ended up in that quadrant. So I'm looking at my 45, 45, 90, and remembering that the legs are the same and the hypotenuse is those times rad 2. So when I go to calculate the sine of 3 pi over 4, this position that I'm in, I'm going to do, remember, opposite over hypotenuse, okay, or y over r. Now, in this case, the x would be negative, but we're not using the x because we're calculating the sine, so I'm going to do y over r. And I'm going to get 1 over rad 2, and if we simplify that, I'm going to get root 2 over 2. All right, the last thing we have to look at here is something you may be familiar with from geometry, depending on where your course went. So the length of the arc. So the arc length is saying how long is this part. Everything we've been measuring is an angle measurement, but we have a formula for that. You see the arc length is equal to the radius times the angle measure in radians. Okay? So here, to find the arc length of D, we're going to use the radius, which is 3 inches, times the angle measure, which is this here, which they tell us is 3 pi over 2. And so we would just get that the length of that arc is 9 pi over 2. All right, make sure you leave a question at the end so that we can answer it tomorrow in class.